All right, so we're going to look at the 30, 60, 90 right triangle, but I kind of want to show you that right triangle based on an equilateral triangle. So it doesn't look too equilateral. Let me try to make all sides look like they have the same measurements. All right, so let's say each side has a measure of 2 units. Now, you should remember that in an equilateral triangle, not only do the sides have the same measurements, but the angles all have the same measurements. And the only way for them to all have the same measurements is if they're 60, right? Because all three angles in a triangle must add up to 180. Now, if you drew an altitude is just a perpendicular line from a vertex that splits up the triangle in a very special way. Now, if this angle is 90 and this one is 60, how much must this angle be? The three angles in a triangle must add up to 180. So 90 plus 60 plus 30 gives me 180. All right, so the same thing on the other side. So this should be proof that the altitude in an equilateral triangle bisects that angle up there. Um, I'm not going to do the proof, but we could prove that these two right triangles, because this is also a right angle, are congruent, right, by hypotenuse leg. That's one way we could look at it. If this is the reflexive property, we know that the hypotenuse in both of them are the same and the leg is the same. So they're congruent by hypotenuse leg. And if they're congruent, then that means that this piece must be congruent to that piece. So if this entire side is 2, but the left side and the right side must be equal, well, that means that the altitude is bisecting that side. So this side has a length of 1, this side has a length of 1, the whole thing has a length of 2. All right, so what we really want to focus on is this 30, 60, 90 right triangle. Um, I would like you to try to calculate the length of the altitude for me using the Pythagorean theorem. So that's a squared plus b squared equals c squared. A and b are interchangeable. C must be the hypotenuse, though. So let's put that in first. A is 1 and b is x. 1 squared is 1. 2 squared is 4, minus 1 on both sides. Take the square root on both sides, and that gives me the square root of 3. All right, so the length of the hypotenuse, the length of the long side of that right triangle, if this is 1 and this is 2, the length of this longer side here is the square root of 3. I'm calling that the long side, and this is the short side, and the hypotenuse is just the hypotenuse. 60, 30. This right triangle is very important to many things in mathematics. They have some really nice benchmark angles there. Try to remember that. So this is the triangle we'll be focusing on. Now, one thing you should take note of or experiment with is if you had another right triangle, let's just say where the side is 4, right? Think about the equilateral triangle. Every side is 4. I'm erasing that. So how long would this side be if it's a 90, a 30, 60, 90 right triangle? Well, this side will be half of whatever the hypotenuse is. So this side will be 2. And then what would this side be? It would always be the square root of 3 times whatever the long side is. I'm sorry, square root of 3 times whatever the short side is. All right, so if we had another triangle, let's say I'm making this up now. All right, so I had an equilateral triangle. I split it down the middle to get my 30, 60, 90. And I told you, hey, each side of that equilateral triangle was, let's just say, help me make up a number here, 30. Then how long will this side be? It's half of this hypotenuse, so this is 15. And how long will this side be? It's the square root of 3 times whatever the short side is. And if you don't believe me, you could erase this, do the Pythagorean theorem, and find it, right? And you may get a different looking number, but if you type in 15 times the square root of 3 in a calculator and you get a decimal, and whatever you got with the Pythagorean theorem and you get a decimal, you'll see that they're exactly the same. All right, so just to summarize, once you know the short side, the hypotenuse is always twice the short side, and the long side is always the square root of 3 times whatever the short side is. So let's use this to do a couple problems. Calculate the lengths of the 5 unlabeled sides. And if you're unsure about that first one, you could just do the Pythagorean theorem on it. All right, so let's start off with that. Find the length of this side. Now, hopefully you remember the shortcut. This is a 30, 60, 90 right triangle, right? Notice that this side is double that 5. So how much would this side be? It's 5 times the square root of 3. All right, try it for this side for me. Find that side. That's right, this is 3 times the square root of 3. Now, how much is this side? You can use the Pythagorean theorem if you like. Well, hopefully you recognize that this is twice the length of the short side, so this is just 6. Now, finally, this one we have to kind of work backwards, right? If this is 2 square root of 3, then how much is this side, right? If you still don't know the pattern, that's also kind of fine. You could create some ratios. All triangles are similar. But hopefully you recognize that this is just 2, right? Because this is just 2 times the square root of 3. And how long is the long side? That's right, it's 4. Okay, so that's a 30, 60, 90 triangle. I hope you get the gist of it. Here's one final question just to really test you out. Find the length of NL for me. That is 2.5 times the square root of 3. Now find the length of NM for me. That is 2 times 2.5, which is just 5. Finally, I'd like to leave you with this little thing that you could put in your reference chart. All right, this is the triangle we were talking about here. Whatever the length of the side is, this side is just the square root of 3 times it, and this side is just 2 times the short side. And previously, we spoke about if you had a square, right? Remember the square, and we sliced it down the middle there. We made a diagonal. Well, the diagonal is always the side length times the square root of 2.